This is the second part of the lesson, and our next example, I hope you can see that right here. F of x is 2x minus 1, and we want to obviously find out the inverse function. But the difference here is we also have a certain range for the domain. So we told the x only go from minus 5 to 3, so we're not taking the whole range of x, or the whole domain of x. Let's just start with the function as we did before, and then I will deal with this mess. Okay, so first of all, we need to just write that function we said as y equal to x minus 1. Just another way of writing. Now, if you work according to the book, okay, you swap the x and y, and then you find y, or like I kind of just used to it. First of all, I find x, and then I swap the x and y. So I'm going to write 2x equal y plus 1, x equal y over 2 plus half. Okay, so now I almost have that function. Okay, but I have it in a way of x equal y, and we usually put the y as the value of the x. Okay, so I'm swapping. Now I'm swapping x and y, and I just write y equal x over 2 plus half. It's important that when I say swap, I don't mean now find y in terms of x. I'm not saying that. If you're going to try and find y in terms of x, you're going to get back that in the original function. So when I say swap, I really mean swap. Okay? So wherever it was saying x, I'm just going to write y. Wherever it says y, I'm going to write x. So that is my function. Okay? I'll write it maybe as an inverse function. F minus 1 of x is half x plus half. And you can test this. You can put x equal 1, x equal 2. Find the values of these functions and then feed them in here and see you'll get the same values of x. If you've got some time, you can do it. Right, what about that one? Okay, if our x, okay, if the range of x is between minus 5 and 3, okay, then maybe our x's here also should have a certain range. Of course they will. Okay, now how are we going to find? Is x again restricted between minus 5 and 3? Okay, should I just write x larger or equal to minus 5 and smaller than 3, including 3? No, the answer is not. You probably guessed that, isn't it? Because if I'm taking, let's look at that picture that I used before. Okay, this picture shows me what f is. Okay, f takes a bunch of x's and turns it into y's. But the x's are between minus 5 and 3. And that brings me to a bunch of y's, which are also in some kind of range. Okay, we're not going to get all the y's in the world. Okay, now what is the inverse function? The inverse function, okay, takes a bunch of values from the y and puts them back as the x. So this is the domain and this is the range as far as f is concerned. As far as f minus 1 is concerned, as far as the inverse function is concerned, now that will be the domain and this the range. They swapped sides, okay? Because the inverse function takes us from here to there. So now what used to be range now is the domain. So really to find out what's the right range here, I need to find out what's the domain of, what's the right domain of x in the inverse function, I need to find the range of y's. How would I find the range of y's? No problem, okay? So I basically put in this initial function 2x minus 1, I'll put 3 and minus 5. And then I will know what's the y's. So the y's are larger than 2 times minus 5. Looks like 2 times 8, sorry. 2 times minus 5 minus 1. All I did is substitute, instead of x, I substitute minus 5. So 2 times minus 5 minus 1. And it's going to be smaller than 2 times 3 minus 1. So y is going to be larger than or equal minus 10 minus 11. And smaller equal to 2 times 6, 5. Okay? So my final answer is like that. Okay? Let's just get rid of this line. My final answer is the inverse function is x half plus half, or x divided by 2 plus half, and x, the value of the values of x is between minus 11 and 5. Okay, let's move on to our last example. Okay, our last example is quite an interesting one. Okay, we've given a function, 2x plus 2, and we want to find not the inverse function f of minus x, we want to find out a composite function, f minus 1 of f of x. Remember, we did that last week, okay? We looked at things like f of g of x, and we wrote it like this, or we wrote it like that. So we're basically taking an x, we're putting and activating g of x on it, and then we're doing f of g of x. Okay, we're taking the value of g of x and we're putting f on it. Okay, in this case, okay, what we're doing in this specific example, okay, we're taking f minus of f of x. Okay, okay, so we first of all doing f of x, and then we're activating f minus of x. The way I wrote it before, we take an x, we activate f of x on it, and then we implement f minus 1 of f of x. Okay? Right. So obviously we know what f of x, so we need to find we need to find the inverse function. That's not eventually the final answer, but we need to find it. So no problem. First of all, we write y equal 2x plus 2. Now, we solve for x. So y minus 2 divided by 2. X equal y minus 2 over 2. Okay? Right, now, I'm just make sure I've got it right. Okay, and now the second step, we're swapping. Everywhere it says x, we write y. Everywhere we got y, we write x. So y equal x minus 2 over 2. So that's the inverse function. Okay? So we're going to write now f of minus 1 of x is equal x minus 2 over 2. Okay, so now, now let's do this. Okay, so we are trying to find f minus of f of x. So f minus, okay, so first of all, so we're going to write down, let me just have a quick look. Okay, so we're going to write down f, first of all, so we've got an x, and then we apply f of x on it. And then we'll apply f minus of x over us. So I'm going to just leave that empty. What I will do is write, if you don't mind, I'm going to write it here. So we're starting with the x. Now what is f of x? I've got a specific example here. It's 2x plus 2. So the first bit I need to do is 2x plus 2. And now I need to apply f minus 1, the inverse function of 2x plus 2. Because now I don't apply it on x, okay? I apply it on 2x plus 2. Remember this thing, what is f minus of x? It tells you that take an x, if you give me an x, I'm going to minus 2 and divide by 2. But first of all, I've activated f of x, and f of x is double x plus 2. So now, instead of x, I've got 2x plus 2. And now I need to apply f minus the inverse function on 2x plus 2. That's the new x. Okay? Right. So how do I do that? Well, this thing tells me, take my x. What is my x? 2x plus 2. Now my x is 2x plus 2. So I'm going to take 2x plus 2. And it tells me minus 2. And then divided by 2. Okay? That's what it told me. Okay? It tells me, you've got an x minus 2 divided by 2. Okay? Originally I had the x, but first of all I activated f of x on it. I know I'm talking a lot, but hopefully we'll get it eventually. So I've got 2x plus 2. Okay, now I need to activate f minus 1 of it. Okay, and the inverse function on 2x plus 2. What does that tell me? Minus 2 divided by 2. Okay, let's find that out. Plus 2 minus 2, 2x divided by 2. What do we have? X. Let's just take a minute to breathe here. What did we find out? What did we find out? Let me just make some space here. Okay, let's try and understand. I mean, first of all, the answer is, okay, let's just start with the answer, okay? So f of, or inverse function of f of x, the answer is simply x. Okay? But now, what I'm saying now is that we should have known that straight away. We should have known that from the beginning. Why? Let's look at that picture. Okay? We've got a domain, and we've got the range, okay? The original function, f of x, 2x plus 2, takes an x and brings it to a certain value of y. Which value of y? 2x plus 2. Okay, take any x and bring it to x plus 2. Now, I then built the inverse function of x. The inverse function of x. And the definition of the inverse function of x is that I take any y value for x and brings it back to x. Okay? So by definition, if I start with x and I apply f of x, which is what I did in the beginning, f of x, and then I apply f of minus x, I have to get x. That's the definition. That is the definition of f minus, or of the inverse function of x. The definition of the inverse function, okay, by definition, f minus of f of x is always going to be x. Okay, that's exactly the definition of the inverse function. It tells you, take any x, apply f of x. Now apply the inverse function on that y value. You will go back to where you started from. So that's really the definition of the inverse function. Okay? Right, I'll stop here. You guys can do exercise 3.3. I'm going to do another little shortish video for exercise 3.4. See you in a bit.